Hi guys, and welcome to HSC Chemistry, Chemical Monitoring and Management video number 17, Ozone in the Atmosphere. I'm still going to try and do the Chemistry 300, so I'll try and get through this in 5 minutes, but I will warn you there's a fair bit of content in this particular one, so we'll see how we go. No promises. The biggest issue with ozone that we need to look at, apart from how it is formed and how it breaks down, is the fact that its concentration has not been stable over time, and we've seen some considerable changes. And the problem with those changes is how the ozone layer protects us from ultraviolet radiation. We want to have a look at the relationship between each of these two in this video. We've all probably heard of the problem with the hole in the ozone layer, and this has been a considerable problem over many years. More recently, changes that we've made to products that have used chlorofluorocarbons, or CFCs, has actually started to repair and replace the lost ozone. And so this problem is less of a concern than it was many years ago, because we've addressed this issue and tried to turn it around. Nonetheless, there are reactions that are occurring all the time, particularly in the stratosphere, that are resulting in some building up and breaking down of ozone. Where the breakdown occurs at a greater rate, then we get a reduction in the amount of ozone, a thinning in that layer, and some potential consequences in terms of ultraviolet radiation. And this has been observed most particularly in the Antarctic in the spring months. So in order to understand this, we need to have a little bit of a background in ultraviolet radiation. And I'm sure you would be aware that ultraviolet radiation is just one part of the electromagnetic spectrum. It's a type of electromagnetic radiation. As a consequence of that, it travels at the speed of light, which is 3 times 10 to the 8 meters per second. And its wavelength is between 10 and 400 nanometers. And a nanometer is 10 to the minus 9, a billionth of a meter. Solar radiation comes in 3 main classes. A, which is the longest wavelength, and that's generally considered reasonably beneficial. It's used for photosynthesis. It helps us form vitamin D, and we've been told that too much hiding from the sun can actually reduce our vitamin D, and we need to get a little bit of radiation from the sun in order to produce that vitamin D. And it's also ultraviolet A is responsible for our suntans. B is the problem one. B is the one that's considered harmful. It causes, or at least has been linked with, melanomas, cataracts, decreases in the immune response, and so on. It can damage plants, and it can also give us really severe sunburn. Now, in terms of ultraviolet radiation, C is actually the worst. So this is the worst of the 3. But very, very little of the ultraviolet C actually reaches the Earth's surface. So therefore, it's not really one that we consider too much, primarily because we just don't receive very much of it. In the stratosphere, in the ozone layer, pretty much all of the ultraviolet C-type radiation is absorbed, and most of the ultraviolet B, which means we can pretty much just have the ultraviolet A, which is the good stuff, reaching the surface of the Earth. When the ozone starts to thin a little, though, that's when some of this more harmful ultraviolet B can get through, and that's the one that causes the damage. In the stratosphere, short wavelength ultraviolet radiation acts upon oxygen gas to form oxygen atoms. So these can then combine with oxygen molecules to form ozone. In the same way, the ozone can absorb the longer wavelength ultraviolet radiation, which has come bouncing back from the surface, and decompose back into oxygen and the oxygen atom, or the free radical that we've looked at before. These are kind of reverse reactions, and therefore they need to be in balance, and generally speaking they are in a steady state. It's a form of equilibrium where the formation of the ozone is equivalent to the rate of breakdown of the ozone, and therefore we have a consistency in the concentration of ozone in the stratosphere. The problem is if we decrease the amount of ozone, then more of the short wavelength ultraviolet radiation, the UVB, will reach the surface of the Earth, and this is a problem. The reason it's a problem is manyfold. The fact that we get this increase in ultraviolet radiation, particularly the UVB form, can increase the incidence of sunburn and also skin cancers, as I said before, the melanomas. The increased risk of eye cataracts, disease and illness as a result of our lowered immune response. A reduction in plant growth. There's particular interference with some of the mechanisms involved in photosynthesis. The phytoplankton in the sea, on the oceans, can also suffer as a result of damage to their DNA, and also we can get some damage to polymers like PVC as a result of this additional ultraviolet radiation that sort of tend to start to powdery and discolor. So we've got a few different potential problems associated with ozone depletion. Exactly how CFCs are related to the destruction of ozone will be looked at in a subsequent video. Thanks for watching.